Hello and welcome to this new section where we'll talk about API as a service. We will talk about APIGateway. We'll start with getting up and running, see what APIGateway is all about and how to configure it. We'll then see how to get your actual URL and deploy your API using stages and why using multiple stages may not be the best idea. We'll then see how to automate your deployment using CloudFormation. We'll finish with a couple of non-obvious things about APIGateway and things that you may find useful. So let's start with getting up and running with APIGateway. APIGateway is an API as a service offering from AWS. It allows you to expose almost any part of your AWS infrastructure as a REST API. You can write your own APIs or use APIGateway as a front end to existing APIs or services. APIGateway configuration is almost entirely based on Swagger, now called an Open API specification, which is a standardized way of defining REST APIs. AWS supports Open API specification with some AWS-specific extensions that allow for very tight integration with other AWS services. So let's take a look at how to start using APIGateway. When you first open the APIGateway console, you will be given the option to get started with a very nice wizard. If you've never used Swagger or APIGateway before, you can use the example API provided by AWS. It gives you an example API called the Pet Store, which shows some basic configuration options and different endpoints. You can see the example Swagger definition over here and different paths that are specified. You can also see the AWS specific integrations. In this case, this is just a mock integration. Doesn't do anything other than return the response as specified in the config. In this example API, you can also see other types of integrations with the APIGateway and AWS. Over here, you can see an HTTP type of integration. We'll cover all of those in a second when we're taking a look at all the options. If you already have your Swagger definition, you can just import your API by uploading the file or simply pasting your Swagger definition over here. You can also create a brand new empty API and configure it directly from the console, and that's what we're going to do. Inside the APIGateway console, the APIs list shows you the list of all your APIs. This is the test API that I have created. The Resources tab is probably the most important one. It specifies a list of all the resources that you want to expose through your API. You can always create new resource or create new methods for a specified resource. By default, you only have one resource available, and that is the root /. You can add a new method to this resource by selecting Create Method and selecting the method that you want to use. Let's start with a simple GET method. APIGateway is simply a gateway to any backend service. So when we create a resource and a method, we need to configure the integration, the backend, that is going to support this method and respond to requests. You can choose a mock integration, which will simply return a dummy response that you have specified. This is easy to start with and can be used for things like health checks or simply placeholders for methods that are not implemented yet. The most popular use for backend of the APIGateway is a Lambda function. You have to choose a region of your Lambda and choose your Lambda name. There is also an option here to choose the Lambda proxy integration. If you choose this option, your Lambda will receive an event from APIGateway without any request mappings being applied to. We will talk about request mappings in a moment. Your Lambda will also be required to return a very specific response that the APIGateway can interpret. This response needs to contain a status code that should be returned and any content that should be returned to the user. If you don't choose that option, you can take advantage of request and response mapping, which can convert any request coming in and any response coming out of your Lambda using the template that you provide. If you're creating brand new Lambdas that will be used specifically for APIGateway as a backend, using the proxy integration is a good choice, as it takes away a lot of configuration that you have to do in your APIGateway and gives complete control to your Lambda function as to how to parse the requests coming in and what to return. But the mappings of requests and responses can be used if you're integrating with existing services. which we'll cover in a moment. Another integration type for your API Gateway backend is an HTTP. If you're using that integration, API Gateway can simply trigger any HTTP or HTTPS endpoint specified by you in the configuration. You have a very similar option to use the proxy integration, which gives you the same options as using the Lambda functions. Using the HTTP integration gives you a lot of options. For example, you may have an existing API which may not be a REST API, which you may want to expose to your users as a REST API. Using this integration allows you to create a mapping between a new REST API that you're creating and an existing different API that you already have. This also means you can integrate API Gateway with anything that responds to HTTP and HTTP requests. API Gateway can also be used as a front-end to an AWS service. You can, in essence, create your own AWS API. Since all AWS services are exposed through AWS API, which is an HTTP API, you can use the API Gateway to integrate with any AWS service. You can use it for things like triggering your code pipeline deployments or triggering EC2 events, inserting data to Dynamo, or any other service that you may want to use. For the purpose of this example, let's try and go with the mock service. This screen shows you the details of how every request will be processed and returned to the user. On the left-hand side here, you have a client, the user that is calling your API. Every request will follow the arrows that are shown here. You can configure the details of the requests coming in. You can specify authorization type, which can either be none or an IAM. This allows you to take advantage of the existing IAM authorization, where every request that comes in needs to be signed with the signature, the same signature that is used for making requests to AWS API. This allows users to authorize with their IAM permissions and allows you to strictly control access to specific methods and endpoints in your API. You can specify the request validator, that is, whether every request should be validated and which parts of the request should be validated. You can also choose whether or not the endpoint requires an API key. API Gateway comes with a built-in support for API keys. We'll see details of how to create API keys and how to use them with usage plans. But at this stage, all you need to know about API keys is that they're not used to authenticate users, they're only used to identify the user. The request that's coming in should not be allowed any additional permissions simply on the fact that it contains a specific API key. You can also add query string parameters that will be supported by your method, choose whether they are required and whether or not they should be used for caching. We'll see details about how caching in API Gateway works in a second. You can configure the same about the request headers. A very powerful part of API Gateway is the support for models in requests coming in. If you've used Swagger or OpenAPI before, you know that every request that is coming in and every response that is coming out should conform to a specified model of the data. In API Gateway, this is where you specify the model of the data coming in. You can also configure the operation name that should be used when API Gateway generates the SDK. Once your API is ready, you can download an SDK that can be used by any clients and mobile apps to connect to your API. You can always change the details about your integration when you're coming into the integration requests. Over here, you can also specify mapping templates. You can basically convert any data coming in into any format that your backend is requiring. The mapping templates, as this is called, is specified using a velocity templating language, a VLT. If you follow the arrows after this step, the request hits your endpoint. When your endpoint returns a response, API Gateway has to map it back into the response that needs to be returned to the user. You can specify which HTTP response should be returned based on the output given by your integration, and also specify header mappings and body mappings that should be used to map the response coming out of your integration into the response that will be returned to the user. The method response configuration allows you to map specific HTTP responses with specific models and response headers. Usually, when you're defining the response, you would first define the method responses, that is, which HTTP response should use which model of data, and then configure the integration response, that is, how to map the data coming out of your endpoint into the model that is supposed to be returned to the user. You can always test your integration by clicking Test. If your method requires any parameters, query string, headers, or request body, you will be able to specify them over here. You can then click Test and see the request being sent to your endpoint. You can see the request that you've sent, the response status, the latency, the data that will be returned, the headers that will be returned, and an almost full log of how the request was processed, how the data coming into your endpoint looked like, how the data coming out of your endpoint looked like, and how the data returned to the user looked like. This is very useful, especially if you're integrating with Lambdas or HTTP endpoints, as you can see exactly how the data was being processed and any errors that were returned. Obviously, having an API with just a single method and a single resource is usually not very useful. You can always add more resources by specifying their name and specifying their path. This will create a new resource to which you can add more methods. You can configure the methods exactly the same. You can obviously have more than one method for every resource. This configuration will allow your users to send GET and POST requests against the tests resource. Each method can integrate with a completely different backend service. When creating your resources, using IAM as a method of authorization can be useful, but is not usually the use case that you want. That's why you can create what's called custom authorizers in APIGateway. A custom authorizer is a Lambda function that will be triggered before any processing by APIGateway of the request happens. The purpose of such an authorizer is to analyze the request and return permissions that the user making the request should or should not have. This allows you to create almost any kind of authorization that you may need, either for supporting any custom headers that you may want to use, or authenticate users with any backend service. Since recently, you can also use Cognito user pools to authorize users against your APIGateway. In the models sections, you will see the list of the models that you're using for your integration requests and responses. Models are specified using a JSON schema, which simply details the list of properties and their types.